Good morning, students. Now, in our last class, we have discussed the last topic was the torque, angular momentum, and kinetic energy, rotational kinetic energy of a body, which is making a rotation about an axis of rotation. Today, our discussion is mainly regarding a rolling motion. Let us first try to understand what is the rolling motion. Rolling motion of a body, if a body rolls on a particular surface, on any surface, then what is that rolling motion? Rolling motion is the combination of pure rotational motion and the pure translatory motion. It is the combination of pure rotational motion and pure translational motion. How? Then in a rolling motion there is a rotational motion as well as the center of mass of the body will always make a translatory motion. Because I just tell you, see, suppose you try to understand like this. Suppose this is a solid cylinder or a disc, anything. Its center is here. It is rolling, suppose, on this surface. Here is a point P, a point of contact. It is rolling, it has this motion. Its center of mass will go straight. It rolls. Obviously, we are considering the rolling without slipping. Mind this. We are considering here the rolling without our condition is rolling should be such that there should not be any slipping. Then what will happen? It will be pure rolling. There will be a rotational motion as well as there is a translatory motion of the center of mass. Its center of mass will move straight. That is called a rolling motion. Our very important discussion, I am going to make a very important discussion. That is a solid cylinder, motion of a solid cylinder rolling down an inclined plane. A solid cylinder is there. I have told you regarding the moment of inertia of a solid cylinder. So let us consider the motion of a solid cylinder rolling down an inclined plane. Fine. What will happen? If a solid cylinder, obviously its cross-sectional view is seen. This solid cylinder is rolling down an inclined plane. And suppose this inclined plane which is there, that is a rough inclined plane. It's not a smooth, there is a friction. We are considering a friction. I'm coming to that point later on. Then what will happen? Try to understand. This is a solid cylinder. Its cross-section is seen. The flat surface, the circular flat surface is there. It is rolling down. When it is rolling down, as I told you, there will be the rotational motion, pure rotational motion, as well as the pure translatory motion. It will be rolling down like this. What will happen? Its weight mg. Let us account for the different forces. Its weight mg, vertically downward. This angle is theta. So you know mg can be resolved into the two components. Very many times we have repeated this. This mg is here resolved into two components. One is mg cos theta in this way, mg sin theta down the inclined plane, and obviously it has the motion down the inclined plane, so a frictional force F will be acting up the inclined plane. Frictional force F will act up the inclined plane. Very clear? So frictional force is acting up the inclined plane, it is acting down in this way. No problem. So what will happen here? Here what will happen? In this case, we can say equation of motion will be mg sin theta minus F should be equal to m into mg sin theta minus F is equal to m into A. That is a very well-known formula. All of us are agreed with this. So this will be here. And then what will mg sin theta minus F, that is equal to this value. Now, here if you say it is motion, there must be a torque. For what the torque will be there? Torque का सोर्स क्या रहेगा? टॉर्क के लिए एक फोर्स का होना जरूरी है. नाउ इफ आई आस्क यू which one is the force responsible for the torque? Whenever there is a rotational motion, there must be some torque. We all know that without torque, the rotational motion cannot occur. So, if I ask you, then which force should be responsible for the torque? Obviously, the tangential force will always be responsible for the torque. I have told you there. This force mg sin theta cannot produce a torque, है ना? क्योंकि हमने कहा था r वेक्टर क्रॉस f वेक्टर, तुम्हें याद होगा टाउ इज इक्वल टू r f sin थीटा, है ना? जिस समय r वेक्टर और f वेक्टर के बीच का एंगल 90 डिग्री होगा, तुम्हारे ऑलरेडी वी हैव डिस्कस्ड प्रीवियसली, इफ थीटा इज इक्वल टू 90 डिग्री, तो थीटा 90 डिग्री कब होगा? जब r वेक्टर और f वेक्टर के बीच का एंगल 90 डिग्री होगा. r वेक्टर क्या होगा? इसका रेडियस, और f क्या है? f is the force which will be acting in the tangential direction. इसका मतलब क्या होता है? Always the tangential direction will produce the tangential force will produce the torque, not the radial force. You just go back to that portion of the torque where I have discussed the torque on a particle. In that, you go to that, you will get this expression. Tau is equal to r into f into sin theta. I have told you, if theta is equal to 0 or pi, no torque. थीटा का वैल्यू 0 और पाई कब होगा? जिस समय फोर्स r वेक्टर का पैरेलल होगा या एंटी पैरेलल होगा, यानी फोर्स रेडियल डायरेक्शन में होगा. जब भी फोर्स रेडियल डायरेक्शन में होता है तो कोई टॉर्क नहीं रहता है. ऑलवेज इट शुड बी ड्यू टू द टेंजेंशियल फोर्स. वो टेंजेंशियल फोर्स कहाँ लगेगा? ये देखो यहां पर, अगर यहां पर मैं एक पॉइंट ऑफ कॉन्टैक्ट P मान लूं तो इस पर फोर्स F एक्ट करेगा. ठीक है? सो हियर the torque tau should be equal to F into R. F into R. R is the, what is R? R is the radius of the cylinder. Cylinder का ये radius होगा. R is the radius of the cylinder. Now tau की जगह हम क्या लिखेंगे? I into alpha. We have already discussed in the last class. The torque is equal to the product of the moment of inertia and angular acceleration. Alpha is the angular acceleration. That is equal to F into R. And what is I? What is this? What is alpha? Alpha का वैल्यू कितना होगा? बताओ. What will be the value of alpha? अल्फा का वैल्यू हम कैसे निकालते हैं? हाउ टू फाइंड आउट द वैल्यू ऑफ, यू कैन से अल्फा विल बी इक्वल टू a by r. A is the linear acceleration by r. That also I have told you. That is equal to F into r. Here A is the linear acceleration and alpha is the angular acceleration, isn't it? So what is F? Let us find out the value of F. F is I A by R square. Alright. तो अब हम क्या लिखेंगे? Now from above equation, what we have? mg sin theta minus I A by R square is equal to m into a. From this above equation, which equation? This equation. Then how much we are getting? I have to find out the acceleration. So a m plus I by R square is equal to is equal to mg sin theta. I can write, or I can write a into m 1 plus I by mr square is equal to mg sin theta. This can also be written from both the sides, m will be cancelled. I will write here a into 1 plus I can be written as m into k square. याद है k is the radius of gyration divided by m r square is equal to g sin theta. Here m and m will be cancelled. So what is the final value? It is equal to g sin theta divided by 1 plus k square by r square. You can write this. This is one expression. Look at this here. I can write this one. This we are getting one expression, that is a is equal to here like this. ये तो निकल सकता है. अब चूंकि ये एक्सप्रेशन जनरल एक्सप्रेशन है, किसी भी शेप का बॉडी के लिए एप्लीकेबल होगा, लेकिन अगर मैं यहां पर सॉलिड सिलेंडर की बात करूं, इन केस ऑफ द सॉलिड सिलेंडर, इफ आई टॉक अबाउट द सॉलिड सिलेंडर, then what will happen? So in case of the solid cylinder, what will happen? I am coming to the next, in the next lecture. I am just putting it in that form, or you can say this way, for a solid cylinder, इसी में लिख लो a is equal to क्या होगा, g sin theta divided by, यहां से लो g sin theta divided by 1 plus I by m r square. और तुम्हें याद होगा I सॉलिड सिलेंडर के लिए m r square by 2 होता है, यानी g sin theta divided by 1 plus m r square by 2 m r square. m r square कैंसिल हो गया, तो कितने के बराबर होगा, g sin theta divided by 1 plus half means 3 by 2. How much it is? It is equal to 2 by 3 g sin theta. This is the value of solid cylinder. Acceleration of the solid cylinder down the inclined plane. This is the acceleration of the solid cylinder down the inclined plane, moving down the inclined plane. This is the whole thing. Very important discussion.